Hi, I'm Cheryl Leach. In this problem, we're going to be using Newton's method to come up with a general rule for evaluating roots. And to do this, I want to look at a function, x squared minus a. Notice if you find the zeros of this function, you'll get plus or minus the square root of a. And we're looking for the square root of a. So we're going to be able to use this function with Newton's method to find a rule. After we do this, we're going to try out our rule on the square root of 10. Okay, so first we need a rule. So we're going to look at Newton's method. Newton's method says we need to look at x of n plus 1 and set that equal to x of n minus f of x of n all over f prime of x of n. Now, I know what my function is. It's x squared minus a, but I'm missing that derivative. Well, that's a fairly easy thing to do because the derivative here, f prime of x, is simply 2x because the derivative of any constant is going to be 0. So let's plug that in. I'm going to have x of n minus my function, which is going to be x of n squared minus a divided by 2 times x of n. All right, I'm going to do a little algebra to clean this up. I'll get a common denominator of 2 times x sub n. In order to put this over my denominator, I'm going to multiply it by 2 times x sub n. So that's going to give me 2x sub n squared. Now this piece is already over my denominator, so I don't need to do anything about that. But I do have to be cautious about that minus sign. So I'll be subtracting x sub n squared minus a. Distributing my minus across, I have 2x sub n squared minus x sub n squared plus a all over 2x sub n. And finally, that reduces to x sub n squared plus a all over 2x sub n. That's going to give me a rule for finding the roots. Okay, I'm going to go over to my table now, and you'll notice that I already have some values filled in. Now, before I work on that table, remember this is only going to work in the general case. I need to have some concrete numbers here. So this is where we're going to pull in the square root of 10. And I'd like to use this rule to help me calculate the square root of 10. Well, I need a guess to begin with. That's how we always start with Newton's method. And 10 is pretty close to 9, and I know what the square root of 9 is. It's 3. So that's what I'm going to start with for my guess. I'm going to start with 3. And then I'm going to plug 3 into this formula that I created using Newton's method. So I'm going to take 3 squared and add 10, because in this particular problem, the a value is a 10. So I've got 3 squared plus 10 divided by 2 times 3. That gives me 3.16 with the 6 repeated. As usual with Newton's method, your result becomes your next guess. So I'm going to take 3.16 that's repeated, plug it into my function, and I get a new value. And I keep doing that. But remember, I'm looking for a result that's accurate to 3 decimal places. And as I've gone through the first 2 iterations, I'm not accurate enough yet. So I keep repeating the process, and finally when I get to this 4th iteration and I compare my values, I notice that I am within 3 decimal places accuracy. So this is telling me that the square root of 10 is approximately equal to 3.162278. Now, if you think about this, this makes sense because 10 is larger than 9. So I know my answer should be bigger than 3. But the next easiest square root to take would be the square root of 16, which is 4. And 10 is much smaller than 16. So I was guessing my answer was going to be somewhere between 3 and 4, and it was. I hope that's helpful. Thanks.